Hello everyone, welcome to our lesson number 9. My name is Professor Robert. In today's lesson, we are going to learn how to graph intervals on number lines using inequalities. We'll start off by looking at the symbols we use, and the first one is very common to everybody, the equal sign. This one denotes is equal to, but then the reverse of that one represents is not equal to. For example, 5 is not equal to 8. And yet, if we just wrote it as 5 is equal to 5, that would be the reverse of what the is not equal to sign stands for. Next sign is the less than. This stands for is less than. And you can use an example of, say, 12 is less than 20. And then the next sign is greater than. Is greater than. And we can say 15 is greater than 9. Now the next one can be derived from the second one. Less than or equal to. So this one is less than or equal to. And you can have an example of, say, 25 is less than or equal to 25. And then the next symbol is derived from the third one, and it is represented like that, and is read as is greater than or equal to. And indeed, we can say 19 is greater than or equal to 19. And then finally, we have the symbol of approximation. It's normally a wavy symbol like that, and we call this is approximately equal to. For example, we can have 1.999 is approximately equal to 2. Okay, now let's get into the graphing of our inequalities. And we'll do that by using examples. So since we are graphing our inequalities on number lines, we draw a number line. Of course, as usual, number line is centered at 0, and on the right hand side we have positive values 1, 2, 3, 4, and so on and so forth until positive infinity. And then on the left hand side we have -1, -2, -3, -4, and so on until -infinity. So on a number line, as we've seen in our previous videos, numbers decrease in value as you move to the left, and they increase in value as you move to the right. Now, let's look at some examples. So if we say 5, is equal to 5, how do we present that on the number line? It's always the distance from 0. So 5 will be represented just by a solid circle like that. That represents 5. Okay. Now, next, less than. So if we have an example, like say x is a number, but it's less than -2. That means we come to the point of -2 and we draw a small circle, not completely shaded as the case is with 5 here, and we are told that x is less than -2. So then we draw that arrow, an arrow moving in that direction, and this will be x is less than -2. All right. Now, the third symbol is greater than. And let's take an example of x is greater than 1. That means we'll go to the point 1 on our number line. And again, we write a small 0, but not shaded. And we know that x is greater than 1. So we then draw the arrow moving in the right hand direction. So this will be x is greater than 1. That's how it will be represented graphically. Okay, now let's look at another example that uses our symbol number 4. And we've said this symbol number 4 is less than or equal to. So if we have a value x and we are told it's less than or equal to 2, then that means we come to the position 2, and we draw a circle, but it must be shaded because it's either equal to 2 or less than 2. And then we draw the arrow in the left-hand direction. This will be x is equal to or less than 2. How about the fifth sign? Is greater than or equal to. So if we again use an example of x is greater than or equal to 3, then graphically we come under 3 and we draw our circle, but we shade it, small circle, but we shade it, and we are told that x is equal to 3 or greater than 3. So our arrow should point in the right hand direction, and that will be written as x or represented as x is greater than or equal to 3. All right. And then, of course, for the last one, if we are looking for a number 1.999, which is approximately 2, we know that 1999 is somewhere just close to 2. Yeah. So we can say it's somewhere there. Not exactly at 2, but somewhere there. And we'll present it with a very small dot that is shaded completely. So that's really the gist of our graphing. But it can get a little bit more sophisticated or complicated, though not so much. So let's look at a number which is represented by 2 inequalities. If you are told that a number x is equal to or less than 5, and it's greater than -2, again, we come to our number line. We are now all used 2. And the center here is 0, 1, 2, 3, 4, 5, 6, 7, and so on until positive infinity. And on the left-hand side, we have -1, -2, -3, -4, -5, and so on until negative infinity. So our number x here, we are told, is equal to 5 or less than 5. So we come at point 5 and we draw a small circle, but we don't shade it, just a small circle. And on this side, we are told x is greater than 2, or -2 is less than x. So we come to the point -2, and we draw a small circle, but leave it, we don't shade it. Sorry, if I can go back a little bit. X is less than or equal to 5. The circle should be shaded, if you remember that. But for -2 is less than x, we have to just write the small circle, but not shaded. And then we just join these 2 points. So this will represent our expression here. -2 is less than x and equal to greater than -2. And our x on the other side is equal to or less than 5. So that would be our graphic representation of that a little bit more complex expression here. Okay, if this lesson helped you, don't forget to like, share with your friends who may need it, and subscribe for more mathematics made simple lessons. See you in the next lesson, and bye for now.